research investments over NAB and been involved in this overuse term big data now for more than about 3 years. I'm looking forward to where it goes next and where Ruby is today. A really fun group of panelists here, starting with I think was one of our chief troublemakers here, Reverend Nerdra from GE Healthcare. And I call him a practitioner, but in his world, it's already a very different connotation. So he'll quickly introduce himself, and you'll see what I mean there. Jack Norris from NAPAR joined us as well, and we'll have some interesting perspectives as to where the new distribution world is going. And Stefan from Dataview will give us some excellent use cases with regards to how it's being applied, how he's actually seeing customers transform business through data. And I don't want to speak for Chris too much, I'm going to let everyone introduce themselves, but Chris was one of the founders of OpenStack. Currently runs Nebula right now, and will give us a perspective for how this technology, how these big data workloads are deployed across massive programmable software-defined infrastructure. So with that, a quick intro for every one of the panelists, and then we'll start off with some prepared questions. In case people get shy, we do only have 60 minutes as opposed to 90 yesterday. I love audience participation in our panel, so pretend this is Twitter, and someone's written something you disagree with. Usually that fires up a lot of discussion on Twitter, so pretend this is the same thing here, and feel free to step up to the mic in the front or the mic in the back with any questions you have. Everyone, please introduce yourself.
Thanks, Bill. I'm Evren. I'm the software CTO for GE Healthcare, about a 19 billion segment of GE, and we provide solutions end to end. And I was just talking at a different panel, and I see some from there. We had fun. It's all about big data, what it does, and what it means for us. Looking forward to it. So, more questions. I know many of you have questions we could ask.
I'm Jack Norris. I'm CMO of MapR. MapR is a Hadoop distribution, recently ranked the top distribution by Forrester. And our focus is really on helping customers achieve production success in a variety of use cases across industries.
Hello, I'm Stefan, and I have a little bit of background in big data. I'm one of the 3 guys that started this thing called Nudge, that maybe calls Hadoop. I'm running a company called Dataview. The way to think about Dataview is really sitting on top of Hadoop as kind of the new generation of business object or Hyperion, kind of end user tool to actually make all that beautiful data that's sitting in the underlying storage and compute actually meaningful and structured.
Did you also design the elephant?
Yeah, I'm sorry.
That's some Hadoop credit.
It was an engineering creativity.
It's so that's a really interesting topic though, because actually
I can see next to Stefan.
These are my
Perfect timing.
So what's really interesting is that Hadoop is actually the first open source project that created the market. If you think about Linux, you first had the commercial Linux, then you had the open source, or the commercial Unix and open source Linux. Or if you think about G2E, some had a G2E container, and then you had JBoss and so on. What is fascinating with Hadoop is that an open source project actually created, what is it now, $20 billion market? And I think that one interesting perspective of this normal open source projects we're getting there is branding from the beginning. And by mistake, we made a cute yellow elephant that's, I can't see it anymore, but people like it. And it really created a brand, and today there's so much amazing technology behind that yellow elephant. It's not really that Hadoop, file system or MapReduce anymore. There's so much amazing technology behind them. It's really interesting.
So, believe it or not, Chris, we're still in the introduction phase, so you have to feel free to introduce yourself.
I think this mic works. And I apologize, we have an OpenStack board meeting going on actually concurrently with this session, so I'm trying to balance something out. I'm Chris Vamp. I was one of the co-founders of the OpenStack project and founder of Nebula Inc. We make a little hardware appliance and plug servers into a little Amazon OpenStack cloud. And I guess by way of introduction, we see a lot of correlation between what's happening with big data and the software and infrastructure companies are buying when they are building out these applications and cloud. So I think that this is a great panel that we can explore some of the overlap there. And what's also interesting is some of the hardware that Dell and HP, Supermicro, and other companies are building to support Hadoop is quite ideal for some of the private cloud infrastructure that companies are building. So there's just a lot of interesting overlap, at least both the hardware stack and the software stack that's emerging. We just did a really interesting study with the guys from DataStax on Cassandra performance on private cloud and public cloud infrastructure.
Excellent. So as you can tell, we've got a nice diversity here between technology founders, technology vendors, and hands-on practitioners, as I like to call them. So let me start off, Evan, with you, actually. Just a high-level question. This is not everyone's first big data rodeo, I think. Certainly not on stage here. Certainly not in the audience. I'm a big fan of Gartner's Hype Cycle. So what I'd like to just ask each one of the panelists as an opening question is, where do you think along the Hype Cycle the abuse, overuse term big data is today, and why?
You know, somebody actually in the previous panel asked the same thing. We just began the journey, if you ask me. We don't even know how big the big data is. Maybe if I were to look at it from a healthcare perspective, we're just scratching the surface. There's lots to be done. And we're trying to figure out, you know, infrastructure, the hardware, the software, to kind of getting the insights to it. Many are trying to learn what is it. It's going to be one of those one bites, and I think it's going to revolutionize. You know, whether it's the healthcare or the power, aviation, transportation, it doesn't matter. This is the new way of doing it, and the architecture is going to come big, and those who are actually watching it, they're going to be like, they're not in it and thinking about it, doing something about it today, they're going to be pretty much out of the game.
You're still seeing sort of peaking towards that.
And maybe even earlier than that.
I think we're going in order.
We'll try. We'll try for now. So
All right.
I can tell.
I can tell Stefan doesn't have to say. Well, first of all, I don't know how you cannot look at this market and say, well, there must be a lot of hype. Everyone's talking about it. You know, the information about Hadoop, et cetera. There's so much going on, but it's a hype cycle if there's no results that are happening. And we're seeing a tremendous amount of adoption across industry. There's definitely those that are at the experimental phase that are still kind of playing with it. But there are customers that are really driving some significant results. And the difference is that they're doing things with operations and analytics in a very tight cycle, in very fast micro decisions that don't involve humans, whether it's fraud detection or recommendation engines for retail or sensor data in the manufacturing side and doing supply chain operations. And so what you see is these massive amounts of impact and things that are not previously weren't being able to do effectively. Rubicon Project is 100 billion ad auctions a day on an MapR platform as one example. And we're seeing it in telco and ad media, et cetera. And about 80% of our customers expand their cluster within the first 12 months. The other aspect of hype cycle, and I'll try to keep this short, but the other aspect is, do you surprise someone, right? And that's what introduces the trough of disillusionment. I had this vision of what it could do, and you surprised me. And I think there are, in the community as a whole, we are setting some customers up, talking about enterprise grade, talking about snapshots, talking about real time, when there's a vast difference between architectures and how they're actually being delivered and how they're not being delivered. And I can go on, but I'll tell you.
Can I make a quick poll? Who knows Crossing the Chasm, the concept of Crossing the Chasm? Yay, great. Okay. Who knows? No. So I think you're at the Gartner hype cycle wherever you want to be as a company. And I think one major observation though is that you can overlay the hype cycle with Crossing the Chasm. Right? So you have the first bit where all the technology people are really excited in Crossing the Chasm. That's the peak of your hype. Right? We're all, in case you can't tell, I'm an engineer, but we're all really excited about all the CPU power and the distributed and having all the many blinking lights in our data center. That's the peak. You go down when you actually realize, okay, well, I guess I can't build all this in spaghetti code and duct tape it together. Because the engineers love to duct tape things together, in case you never figured it out. And you make it over the chasm if you actually, as you just pointed out, really looking into where is my return of investment, where is my business problem. And I think, and again, I'm an engineer, but I think what's really important is to take out that technology hype in the engineering department and move it in the conversation to what I call the subject matter experts. We cross the chasm and we make it over the hype cycle, the plateau of productivity. If we're actually looking what is the business use case we can resolve rather than like, oh my god, I have so much CPU power now in this cluster. So I'm doing this since 10 years, and I had companies in Cupertino, maybe one big company in the mid-2000s, that got the idea of Hadoop, implemented it, long before Yahoo was on board, Hadoop cluster, built an amazing smartphone on top of that, and got really successful about it. And it was about technology, it was about end user experience that we looked into. And we're working with companies today, and it's again the classical crossing the chasm technology adoption cycle, Google later, let's say manufacturing business, adopting things a little bit later, right? And the other stage that they're really trying to figure out where's the technology now. So it really depends where you want to be. And I think what's important is to recognize different tools in the tool set. Hadoop is not doing your dishes, and it's not printing money. It's really important. Your Oracle database or MySQL is actually really good doing something that doesn't print. So you really have to be smart.
I can say some things about Hadoop and printing money, but I think if you look at this from a technology perspective, when you think about a hype cycle, there are some technologies that are driving change, and then I think there are some examples of technologies that are in response to changes that are occurring. And I think the interesting thing about big data is it isn't necessarily the leader in this transformation. If you think about some of the companies that are driving this, and let's look at the network, for example. I was reading that in 1995, the entire global internet traffic routed across all of the networks was equivalent to the average internet traffic in 20 broadband households today. Put it in perspective. It's an amazing statistic. This came from a very comprehensive study of the internet. The three largest network providers in the world today are not AT&T telcos, the traditional sense. They're level 3, Global Crossing, and Google. These are all companies born in the internet era. You have companies like Google and like Facebook that are literally storing so many photographs, it's transforming the computer industry, the storage industry. Frank Frankowski is leading a compute project, left to go do some sort of crazy optical storage robotics type company thing. So when you look at the things that big data relates to, they're really filling in gaps between where some very pioneering companies in the internet space, where we've transformed the way we interact with people and information through search and social, and it's transforming the hardware. That's actually pulling this big data thing along. So then we get back to what is a hype cycle? There are thousands of companies that have no idea what's going on, right? And if you think about the products we're all trying to sell, we need to sell them to people who know how to use them to transform their businesses. And so when you look at it from that perspective, I think we have a lot of work to do before the technology that we all take for granted, Google and Facebook take for granted, becomes mainstream in the principal applications that drive most of our economy. And I think we're probably very early on about a 10 to 15 year journey where the technologies that companies within about a 5-mile radius of right here take for granted, and all of the big Fortune 500 companies out there, we actually see the transition to the kinds of technologies we build and develop, and when they put that into production, and they start to power their core applications using this technology. So does that help?
That's a perfect lead-in actually into my next question. Yes, it helps a lot. And this one will just sort of not necessarily in order, whoever wants to jump in first. But to that point, I always refer to this thing called the hoodie index in my discussion with customers, which is how many hoodie engineers can you afford to hire to stand up some of these leading edge technologies? The hoodie index is high now. It's very, very low. Extremely low outside the valley. I'd love for someone to chart that one these days on Venus or whatever. But what are some of the most common mistakes we see the Fortune 500 style enterprise developers that lack access to utilities make in deploying successful big data projects? And we can start with Daniel.
Okay, then maybe I start.
He created the problem.
Oh, by the way, I love this hoodie index thing. I will definitely take that to our next customer meeting at Wall Street. So we work with a lot of banks, and we share a lot of amazing customers. So what they do is just mind-boggling. But I think what I observe a lot with very, very good companies is that especially IT folks are super excited to get their hands onto that new technology, put it on their resume, and guess what happens 6 months later? Right? So you work for, let's say, Bank of America, and you're really excited, let's install that do, let's duct tape something together, let's write all those scripts, let's put it on my LinkedIn profile. Oh, I guess I just got a job at Citi, pay twice as much. Right? So what we see is really a lot of risk associated with, oh, we're smart enough to do it ourselves. Nobody today would, I would argue, would build their own CRM system. Everybody would buy Salesforce, Zoho, what else? NetSuite, I guess. But people are thinking, okay, let's build this whole thing from scratch, right? We download some open source cloud management, we change that a little bit, and let's install it. But now the reality is that today, and one of those hoodie engineers makes a $200,000 annual salary all the way in. You need at least 5 of those hoodie guys. I think they wear hoodies and drive Ferraris. Right, that's $1 million a year. You know, if you go to one of the companies that actually provides you a ready-to-go solution that tested it with hundreds of customers, most likely you'll pay significantly less, and guess what? You're up and running in a few weeks. Again, I'm a technologist, I'm an early adopter, I get lay sketches, I love to duct tape them together, and that's a little bit a sickness we all have. We're very innovative, but then we can't really make it production ready. And that's what we consistently see with companies. Like, we have the smartest people on the planet. Yeah, you have, but they're usually really smart in your business, not in the underlying technology infrastructure. And you usually shouldn't use them to plumb things, do the data plumbing. You should use them for your specific, expertise in your area. And that's what we see constantly.
Let me build on that, since I work for one of those big ones. And if you haven't noticed, and it is a big company, and it's one of those more innovative companies out there. And the way that we're tackling this is actually we're living in an environment. So it's an augmentation. You can't just omit what we have in the world. And you're right, we're all aware of it now, we cross the chasm, until you find a solution that is actually pursuable, widely mainstream, you're going to end up having all these early adopters. But you need them. So the way that we actually tackle this is, we're here, and if you haven't heard, we have a big center. So we were able to hire about 1,000 people in one week, and 1,000 people from here. To augment the domain, the capabilities that we have, so we can actually build solutions around big data analytics, therefore English, that's what we're on it. And we know that we can actually stay on it for years, to deliver these. This is not a journey of 1 year. It's not a hype for us. It's a business strategy. We're in it. GE is a really old company, but it innovates itself regularly. That's what we're doing right now. So the GE that we know today is that we're ready to do utilities that we're doing. It is not successful to set up a company, 2 people in it, and yes, they will all company, but is it going to solve the needs of the masses? And I can assure you, not in healthcare, there is a lot that
it takes a lot more. But bringing the two together, the good index, the great configuration, you can never lose sight of that domain. And I totally agree with the notion. Use your talents where you need to go. I want to use your hardware, I want to use your software, because I want those things again. The domain that we have in the business, right, makes sense.
So I think the biggest mistake is where to apply the hoodies. So having the hoodies work on your business and how it can make a difference. And the other is it's really kind of MapR's mantra is architecture matters. And if you're using Hadoop for mission critical or important data, you need to make sure that the architecture is up for it, because it doesn't matter how many hoodies you have, it can't recover lost data. And that's probably the biggest difference in terms of kind of this early cycle in terms of the technology. So combining open source with some architectural innovations is really what kind of propels this forward and makes it useful for a broad set of applications.
So, I mean, one way to put it is, the future is kind of pioneered by the hoodies. And when companies see this new, shiny new technology, they'll maybe hire some hoodies. They'll hire some consultants. These guys think they can do anything. And they'll often start building out some of this technology in-house as a prototype, as a proof of concept, as a pilot, whatever you're going to call it. I think that the mistake that companies make is as they start to prove that technology out, they don't say, hey, listen, this is not something that we need to be experts at. And while the future is pioneered by hoodies, the market is pioneered by products, right? And I think Hadoop's a great example of this. It was pioneered by hoodies. It was developed in internet companies. But it took a few years for companies to emerge, like MapR, that could take this technology and deliver it as something that you could consume in the enterprise. And boring things like documentation, boring things, like really good support, and an ecosystem of compatible products, right? Integration with existing identity management systems and storage and all that stuff. And I think that the challenge is it always takes about 5 years for that to happen. OpenStack's a great example. So the mistake that all the companies are making right now is they're downloading all this open source stuff, and they're getting a couple of hoodies and they're trying to put it in production when they should be actually looking at the products that are emerging around these open source technologies and selecting the best products. And then focusing on the business.
Products and services. A lot of these technologies are available online.
As a service.
Not necessarily on that.
We get the one if we can service scale. That's why we really go to stages always.
You got to pick where you put the hoodies.
The basement.
Right business.
And it sounds like GE's trying to talk to the hoodie box.
Oh yeah,
and corners of
great
the
place. We want them to want to come there and play, and this is not a recruiting call, but if you're interested, shamelessly, that's why I'm here, right?
You got the mic.
And yesterday I was at the Silicon Valley Innovation Forum. Hundreds of people there, right? With the same thing. This is how you change.
Let's follow up on that. We talked about some of the lessons learned. How about some of the more aspirational things? So, can you give me one or two examples of the coolest use cases you've seen? Whether it's a big brand new company you're allowed to name, or whether it's just a really cool project, presumably with some really powerful business value.
I just played a video that we released into the market, and a few years ago, no one actually thought that we could do it. This is, I don't know how many of you are familiar with what's called the tumor board. Okay, so tumor board is something I'm learning, not a doctor. There are cancer patients or stroke patients or whatever is very, very rare, and they're trying to bring in all these smart brains from different places to really ask the tough questions for themselves and find a way to cure and care and whatever it is that it takes. And the reason it's called board is these are all individuals, highly skilled individuals, talented people, who while together. So they can actually come together with the patients and all the information, but this is needed instantly in some cases. If it is a trauma case, you need to have access to the information by twice. And it turns out, in these cases,
they meet maybe once a quarter, and they can have 1 hour for that patient, and they spend a good portion of that 1 hour trying to remember what they have done last 2 months. And they wasted about 30-40 minutes, and then the time that they have left, oh, maybe we should try this, maybe we should try that. Wouldn't it be nice, they said, if I had actually information, like pathology information, image information, health records, this and that, instantly, so I can remember where I left off, so I can actually have the patient there. We're able to actually do this big data evidence scale, all clouds, all about analytics, bringing it together. We work with some experts from the University of Washington, Stanford, and whatnot. They are the ones who are driving, and they are describing their need. Our job is to create a platform. We did it. Deliver this for them. Developing it. This is just the beginning. Now, do they care if I have Hadoop behind it? Do they care that I wrote it with the latest software technologies? No. We're trying to solve a problem. Save a life. To me, that's good.
Center bar high, saving lives. What cool are the cookies?
No, I kind of agree because you can look at the Hadoop platform and get excited that these ad auctions are happening faster, or the Comcast ad insertion that you're seeing on cable TV is pretty important, or the mobile alert that you're getting on your cell phone or your credit card transaction is more secure. But at the end of the day, it's the leading cancer research that looking across 20,000 genomes and 100,000 of patients so they can better understand and predict and impact survival. It's the climate corps that are ensuring the world's farmers and trying to improve farm operations. And it's the ADHAR project where they're trying to reduce government leakage in India through instead of a social security card, fingerprint scans, and really increase economic mobility. And those are pretty exciting. And then I'll add one more, which is at the other end of the spectrum, where you just kind of scratch your head. There's a customer in Japan, one of these big beverage distributors, that are using Hadoop for facial recognition in the kiosks, so that you don't have to push extra buttons, I guess. So we're seeing a full gamut of these.
It's a fun anecdote, but if any of you haven't been to Japan and seen the vending machines they have there, they're out of this world in terms of the sophistication and the variety of products you can sell. Amazing stuff. Very much so.
So when I was making Minority Report relative, I couldn't agree more what you said. We need to move the technology closer to subject matter experts. We unfortunately far away from that because we very much, especially with the data world, at this point, very much looking at bigger, faster, more scalable, more colorful, more customer. In the end, you want to have something like an iPad making the life of the doctor easier and help them to get stuff done. All the stuff behind is interesting for us, but unfortunately, a lot of people that I've worked with in the big data space are really focused on the horsepower of their Hadoop cluster, and that their Hadoop cluster is bigger than their body's Hadoop, but it doesn't matter. Right? The question is how close to bring that data to the subject matter experts. So let me give you two examples. One may be more fun. The US Olympic team used the data meal to actually overcome a 5 seconds difference in the women bicycling team when they went into trains camp in summer before they wasn't even anywhere close to the medals. And then they looked at sleeping patterns, food, blood sugar, performance, weather data. And by bringing all this together, it wasn't, petabytes of data, but the problem, as every company we're working with, their problem was data complexity, sheer number of data sources of data. And they figured out, sleeping at cooler temperature lets you sleep, you have a longer REM stage. In the REM stage, there's more hormones that help you to recover. Get more light exposure early in the day, then you perform better during meals. So what did they do? And basically went to London, switched off the heating, opened the window, and brought some happy lights with them. You guys saw those happy lights? I guess we live in California, you don't need them, right? But they brought them to London in the morning, did like a half-hour happy light session, and they won the silver medal. It was kind of a grassroots project, all self-financed. The next team had a $32 million budget. What was really great there is that they replaced doping with data. So, second, maybe more business-like. We have Telefonica in Germany. Telephone companies are really challenged with which cell tower should we update because the technology is moving so quickly. And they, the very first time, brought all the data together, not just like how much data do we have in the network, how many people are working, but they could associate dollar signs for every cell tower. But they could actually look at, okay, San Francisco Mission, all people are listening to online radio, and they have unlimited data agreements. So let's think about if we want to upgrade data. But over here, limited data agreements and very limited usage, so maybe it doesn't make sense. That was $150 million ROI for 8 weeks. And again, what happened there is that the data came very close to post-concussive network planning. And this is something where we can imagine that.
Yeah, I mean, there's all sorts of really interesting use cases we're talking about big data. Perhaps one that comes to mind is more practical. There's really two kinds of approaches to building a company these days. If you started a company 5 or 1 years ago, you tended to build your own infrastructure. And in the last 5 years, you tended to build everything out in cloud, typically Amazon Web Services. And if you guys have watched the news for the last couple months, there's a lot of M&A activity. And when an old company, big old company acquires a new company, you have a collision of these cultures. Right? You have a company that perhaps built everything out in the cloud, be acquired by a company that might compete with a company that powers that application. This has actually happened a few times, more than a few times recently. So one interesting use case is for companies that operate their own infrastructure, big companies, typically large enterprises, as they're acquiring these smaller companies that are powered on the cloud, but they want to bring that workload in so they can integrate it with their existing application, perhaps leverage their existing infrastructure, their existing peering agreements, and bring the cost out of the equation. Products like ours provide a way to bring the cloud in-house and power a lot of these very large applications on-premise. We had a large photo sharing site that deployed a cloud to move a lot of to move an acquisition in. It was being powered on a big public cloud provider in-house. Interesting practical use case. I think increasingly these technologies we're building, whether they be big data technologies or cloud technologies, will need to integrate into the existing systems that you'll find and will continue to run for the next 25 years in the big enterprises. We're not going to just see that stuff go away. And I think one of the mistakes that a lot of innovators make is they try to envision their technology being the center of the universe and the only thing that exists in the architecture. And it actually takes some time to take the technologies and integrate them into the ecosystem of products that exist in the Fortune 500 companies that are out there. And that's one of the things that slows adoption.
Just a reminder to the audience, please jump in here. We're more than halfway done, and we're going to quickly run out of time for audience questions. So it's the perfect time to think what you want to ask. Please step up to one of the mics, otherwise we can miss your chance to go next year.
No, I was going to say, let's pass it on to them.
Yeah.
I do have one fun example that I want to share with you guys. That one of our clients in Canada is dealing with their power client. And one of their challenges is that they have all these trees that they grow, and they don't have these power lines. And think about it, when they fall down, no one hears that, right? And then the power stops. So through the big data, the study that we're doing, they should go and actually provide some maybe trimming, cleaning, or whatever, so that before the tree falls down. And when it knocks the power out, because it's the middle of winter, is really fast.
That's just very practical. I remember, beating myself.
If you predict a tree falling in the forest.
Well, they actually stand. That's great. It's a big display they have. It actually able to keep forms. Very accurate. All they need is just a little bit of a head start. That's it.
So let's try and stir up this, add a little bit and add a bit of controversy here. Give a vendor fight or vendor predictions. Who do you think is going to be the big winner, or one of the big winners in the big data industry in 3 to 5 years? She made big numbers. So why?
Well, if you look at it, the way that we are approaching it is it's not about the data itself. It's about what outcomes, what solutions we drive in the pillars that we're serving our markets. And we're trying to solve our customers' problems with technology. Big data, your capabilities, something else capabilities, really nice. It's all about the industry's big problems. So if I can solve customers' problems, doctors' problems, right? Plant operators' problems, I know it.
Let me give you an example of what I'm looking for in an answer here. Typically, yesterday made an announcement around a suite or bundling of a whole bunch of offerings with better consumption-oriented pricing. And it's pay-as-you process instead of pay-as-you store. KKK, of course. And Paul Morency, you have that company coming up with a whole back office concept, which is legendary in the Microsoft days. Is that a model going forward? Will Pivotal be one of the winners?
I'll go back to my earlier comment on architecture matters. And Stefan said early on, this is the first open source technology to actually create a market. So we don't have an existing technology stack to look at and understand what the commoditization of that is. And that's really the Red Hat play and the MySQL play. We're commoditizing technologies that are 30 years old. We're at the very beginning. And how you can store and how you can process more disparate workloads on a single platform will be the winning platform. And the Pivotal play is actually the opposite of that. The Pivotal play is we're going to do orchestration at the high level. We're going to keep these point products underneath and move data behind the scenes. It's in the cloud. People won't notice. But the reality is it's about response time. It's about combining deep analytics with low latency, kind of real-time results to power some of these really interesting use cases.
I don't know that I agree with that. I mean, as an investor of Pivotal, I know I don't agree. Because they are building a very, very scalable platform. They are actually building the next generation platform that isn't the and they are with analytics, and forget how they're moving the data and so forth, but it is the infrastructure.
The issue is how, on a distributed basis, you can ensure consistency. And distributed consistency is really the key. You can't do two-phase commit. You can't do an eventual consistency if you're talking about mission-critical data. And that's the platform of the future, and that's really what our CTO architected from the beginning for multiple years.
That's what we have, right? So if you look at how we leverage Pivotal, is about our mission-critical platform, which is what we call the credits. That's what we're building. And Pivotal plays a role there. We make it mission-critical for the industry to serve. So you have to really go to the application, you have to go to the business solution, and how it is integrated. If you're not actually thinking about that architecture at our level, at the business architecture level, at the police level that we're building, then you may be right. But you can't just take what you're hearing and apply it to generalizing.
No, and the ability to kind of file processing.
This is what I asked for, right? This is what I wanted. Let's flip counties and see if you got any questions.
So, being Switzerland of Hadoop world, running on all Hadoop distributions that are available, with now almost 200 customers, I could give some really interesting insights into who's winning the market. I should actually sell the data. It's not so good for the company we heard about. I can say some of the biggest Hadoop clusters I know run them all. And I can give out statistics. I mean, think about how many companies I know that run this out of there. So, I think coming back to your question, what we all need to recognize is a few high-level trends. The winner today is not the one with the most money. The winner today is the company, is the technology that moves the fastest. And you see that on a daily basis. You see 10 guys, maybe not in the garage, building a, excuse my German, a freaking photo sharing app being acquired for billions of dollars. You see another 5 guys building a chat. That's a hell of a world exercise for every software engineer in the world, going for another few $1 billion. So let's be really honest about this. Today, the winner will be that company that is agile, that is moving fast, and that has adoption very, very quickly. And I see the big companies, Larry, Hasso, and put all our names in there. I mean, they play the old game, right? So Larry always say there is no cloud, there is no cloud. I invented the cloud, and we will see the kind of the M&A activity going up. But the reality, the winner here will be the companies that are moving very quickly and have something different. Here's another high-level trend. If you think of the traditional databases, they will reach end of life. Why is that? 40 years ago, when we invented databases, we spent tens of millions of dollars on hardware. We had the people, and I would argue we have the time. Moving to the 21st century, guess what? Moore's law kicked in, hardware is dirt cheap. We now have to call the people that work with data scientists because we can't find them. And we don't have the time. Companies that are 2 years old selling for billions of dollars. The technology that some of the kind of the classical big companies bring to the table is 40 years old architecture. It's highly optimized to get the latest performance out of the hardware. It doesn't matter. Every software developer today uses something, who does web applications using Ruby on Rails, Active Records. He never saw an SQL statement ever in his whole life. For 5 years, this guy's an architect, and another 5 years, he's a CIO. And no SQL is just Samba. Why would you? Who still has a Nokia punch phone that has no color display? All right, what's a smartphone? It's moving quickly. So what's interesting again is kind of the innovator's dilemma that a lot of big companies bring to the table. They're not really aggressively reinventing themselves. They try to resell the same old. And I don't think that this concept will win the market. In the end, I hope the consumers win. Right? That's important, so that we don't just create what we are as technology companies, but make the life better.
And I think to go back and perhaps agree with Jack a little bit, the architecture does matter. And what we're seeing is a whole new generation of software emerge. Adrian Cockcroft has this beautiful slide where he talks about the design patterns in software from 4 years ago, where you have central SQL databases, you have very chatty protocols, you have very large objects, you have in-memory sessions and application servers. And when you look at how you build a highly distributed application, none of that stuff works. Right? So you have new technologies largely developed by the internet companies and open source, by the way, that address these problems differently. And they acknowledge things like Kafka, where you can't have an infinitely large file system globally consistent and highly reliable all at the same time. And what this will drive is a whole new generation of software that runs on this new generation of hardware. And I think the challenge for the incumbents is, especially incumbents that are trying to virtualize everything, is they're trying to virtualize the reality away. And the reality is that these are physics problems, right? These are mathematics problems that can't be virtualized, right? You can't just trick the software into believing that nothing changes. I mean, what VMware and these platforms have done is they've built what I like to call holodeck software. Software that was written in 1995 will run like it's 1999 in the year 2025. And the more they virtualize, as they virtualize the network, as they virtualize the storage, they're freezing time for an old generation of software. And they are creating a new mainframe. And while the mainframes will continue to run for a long time, we'll see a whole new generation of hardware and software move on as a result of mobile and big data that will embrace physics and mathematics and the tough engineering challenges that you have to face when you build and scale applications. And that will change everything. So I wouldn't bet on the past.
Yeah. You said something really great, and I want to add a little bit more food for thought to the audience. The NVIDIA, or in general, virtualization totally disrupted the data center. Do we agree on that? You guys are okay with that statement? So what is that? It's one piece of hardware, one server, one piece of metal, and you created as many virtual machines on top of that. Right? It totally provided you freedom. Now, if you think about what you guys are doing, or what Hadoop, it's exactly the opposite. You just turn it around. You have one virtual machine, it's one horizontal virtual machine, it's one storage layer, it's one compute layer, and you're now getting the memory layer. And you put as much hardware under that as you want. So zoom out of like, oh, this is MapReduce and this is here. It doesn't matter. Right? You have a horizontal virtualization with OpenStack, with Hadoop, and it's just fantastic. And what that means, it will totally disrupt the way you think about your architecture. Because you just add more metal. And if the metal is in your data center or outside the data center, in 2 years and 3 years maybe, it doesn't matter that much anymore as it does. But you have a virtualization layer, you can just go on top of that. And guess what? Your time and the time of your company is 100 to 1,000 times more valuable than the hardware you just put on.
All I want to say is really you guys need to look at really something just comparing to VMware models, maybe the traditional sort of VMware. You really need to understand the underlying theory, the technology, the fundamentals behind what it really is all about, how we're leveraging Hadoop and what you just described. But there's a lot that we can do. I can go on to do what I think you want to do.
I want to ask one last question because we have about 10 minutes left, and I'm not optimistic about audience questions, but I think a good closing question. What is your prediction for where big data will be at the end of the day?
It will be small data.
Legitimate answer, much expensive.
Yeah, well, again, I think there's a few high-level things we have to figure out. One thing is called data privacy. That will be good if you have an open conversation about that. Again, I totally believe moving forward with really cool stuff like OpenStack, storage and compute will be a plug in the wall in 10 years, and it doesn't matter where it comes from anymore. And we really need to solve the business problems. And I really hope that Geoffia is employing more doctors because, to be honest, we really need to solve that and not solve the performance of query, but actually solve the performance of our healthcare system.
So there's certain things we take for
I
granted.
just ask you to make an elevator prediction because they want to get at least a couple of questions that we have on.
Yeah, so I'll just tell you that certain assumptions we have are going to be totally obliterated. One is you have a storage network separate from your compute farm. That's how we expect enterprise architectures to behave. It's totally changed with big data. The second is we have an analytic platform and data warehouse that's separate from production. That distinction is totally eliminated. So it's another way to look at what Stefan described in terms of the flipping over of a virtualized environment.
Oh, no, I don't think we'll be talking about big data in 10 years. It'll be a different name. I heard this morning, and because it's not just a ball.
I think today the world is dominated with the PC architecture, both on our desks and in the data center. And I think in 10 years we'll have a tremendous number of small devices that are just embedded in us, around us, in everything we interact with. And these small devices will talk to hyper-converged, hyperscale computing environments that will be operated by all the big companies.
So we'll go to John. Can I please just ask one question?
My name is Mike Meehan. I'm a video-wearing theoretical physicist who used to work at PM.
Is that a hoodie you have on?
That's all you need to say.
Sort of, yeah. Anyway, so, you know, we're kind of in a data gold rush at the moment, and when you're in a mining gold rush, what you want to do is be selling shovels. This is what people like David Mayer and everyone do. One of the things I saw when I was working on theoretical problems I was dealing with my physics PhD was algorithms were the basis of improving performance over hardware. Wait 80 months to double the speed, but you could sit down, solve a problem, and improve the performance of a calculation by 10, 100, or even 1,000-fold. What sort of technologies do you see coming through from the software side that look promising in that area of improving performance? Because it's really, meantime to answer is what everybody's looking at. Short and price time, what we talk to. How quickly you get the answer that needs to get
I think the thing that's happening that's very interesting is you can actually turn a group of people that are passionate about something like, say, gene sequencing into a technology that can run on cloud at extreme scale, and ideally can be partitioned to run on an arbitrary number of machines. And I think what this will create is a whole renaissance in software where things like rendering, or things like sequencing, or things like analyzing very specialized sets of data, the experts in that can actually form a company that can make a best-of-breed service that can then be incorporated into an application at a very granular level. So we won't have these monolithic applications anymore where we'll have poor implementations of certain things. We'll have applications as microservices implemented on top of world-class implementations of things on top of more commodity hardware that will ideally be optimized for the software.
This will totally not answer your question, it's just an observation. What I thought was really interesting is that Facebook built a multi-billion-dollar company with PhD. And then they just wrote a PhD to C++ compiler. And I think that's kind of what we will see in the future. First, solve your business problem, and then you can work on the optimization. And the optimization usually comes from the bottom up. Because again, today, you can build Instagram and sell for a few billion, and you still run on, some Ruby on Rails. It's okay. It makes a few $1 billion. Technology in that sense doesn't matter.
I think another piece of the puzzle is Google's white paper on the essential effectiveness of data, which is instead of doing a more complex algorithm or a more complex model, expand the data set. And I think that, along with Chris's point on cloud, kind of points to how the future will be shaped.
This is a good one. We all agree. It's not about the software. It's not about the technology. It's got to be very different. Solve the problem first. Keep it simple. It's just models. Keep it simple.
You just want to. All right. Next question.
I'm Jackie Madison from CFP, and this is a question for the gentleman from GE Healthcare, although I guess everybody's welcome to answer. Based on what was just said about the essential effectiveness of data and making the data sets bigger, and all the conversation we had yesterday about meshing really big data sets from different disparate sources, I recently sat through a talk by someone from GE Aviation about sensors and performance of jet engines and that kind of thing. And I'm wondering, are you doing anything between business units at General Electric that could lead to something really, really creative that we haven't thought of?
This will feel like some kind of question. No, I thank you for the question. I don't know you. It's just this little thank you for asking. This is exactly why we have our software center of excellence in here, so that I sit next to my peer fellow software CTOs and their team members. So there is a lot of cross-pollination between the businesses,
that we actually, things that I learned in healthcare and I share with them, they apply to their industries. That's how I was actually able to move from transportation to healthcare business. We do a lot of cross-pollination, cross-sharing through that sensor, through the platform that we're building together. Because in the end, the problems that we're trying to solve, when you get up a little bit, is very similar. And we did have at one point in my history, I heard, oh, healthcare is different. No, healthcare is not different. The healthcare industry may have this arrogance about it a little bit. But it's about data, it's about how we solve problems. We do a lot of that cross-pollination. If we didn't do it, we didn't actually do it, we would be serving ourselves. I would actually tell you with my friends in here. And this is an ecosystem, not just with GE, but it's an ecosystem within the cost industries. Thank you.
Thank you very much.
Yeah, no, I
follow up and then,
yeah, really well, if anybody has any other examples about, you know, what's really happening. I think this is really important because this discussion is always around IT. But we know that all the new technologies are going to reinvent the way we do business and the way we live. And I'm just wondering if you know of any other examples of something that's really, really different.
the last word, we want to.
Well, I guess I'll abstract and say that big data is applying to almost every C-level position in the organization. We're seeing, typically in new technologies, when someone says cross-industry, is a small application that's the same applications being used in different industries. And this, what we're seeing is that in a company, you're seeing 10, 20 different applications all running on the same platform. And I think that's just a small glimpse into how game-changing this can be. And I think everyone did start out the session by saying we're at the very beginning, we're just starting to see some of the low-hanging fruit.
That would be a round of applause for this wonderful